Hello everybody, it's Mr. Mulvihill here. Happy Thursday. Last math video of the week coming at you. Got a nice little quote here from C.S. Lewis. He wrote The Lion, the Witch, and the Wardrobe and that stuff, Narnia. There are far, far better things ahead than any we leave behind. And that is true. Alright, so let's check out this math video. I see we had a difficult time with scientific notation. I can take some blame for that. Maybe the last video was a little confusing, so I'm hoping to kind of clear up some misunderstandings, then we'll be good to go. So both these pages are due. I'm going to do like pretty much the first page with you, and then you'll have this last page to do on your own. But both pages are due. Alright, so let's look here. For each question, determine if the number is written in correct scientific notation form. Okay, well, to know if something's written in correct scientific notation form and answer these questions, we should probably know the form. And what that's going to be is a number 1 through 10 times 10 to some power. Every scientific notation thing will look like that. So here's an example. Like, pick any number between 1 and 10. My favorite number between 1 and 10 is 3. So 3 times 10 to the, 8th power. That would be written in scientific notation. Okay, so let's tackle this stuff here. For each question, determine if it is written in correct scientific notation. Well, A is no, because that's just normal. That's called standard form. That's 4 billion right there. B, let's see, is this number between 1 and 10, 3.29? Yeah, that's between 1 and 10. And we're multiplying it by 10 to some power, even though it's negative, it doesn't matter. So, yes. For C, 42.8, is that a number between 1 and 10? Nope, right away, not in scientific notation. Alright, why don't you guys try D, E, and F, and then resume the video, see if you got them right, and then I'll have you try G, H, and I. So pause the video and try D, E, and F. Okay, so for D is yes, 4.1893. That's a number between 1 and 10, so we're good. E is a definite no. You're not even multiplying by a power of 10. The most helpful number to multiply by. And F is yes. You don't need a decimal point. All you need is a number 1 through 10. And 9 is a number 1 through 10. Okay, let's try G, H, and I. You could pause the video and give that a try. G will be no. 0.3 is not a number between 1 and 10. 0.3 is not a number between 1 and 10. Neither is H, and neither is I. Alright, so now that we're good at putting, or at least seeing if numbers are in scientific notation, now we're going to convert numbers to scientific notation. So let's start with A here. A. What we're going to do is if there's no decimal point, we're going to put one where it should be, because we need decimal points to do this. It's all about decimal points. It's not about zeros, really. It's about decimal points. So here we go. We're going to move this number, this decimal point, until we get a number that would work for scientific notation format, i.e. between 1 and 10. Right now, this number is 3 billion, so we got to scooch this number. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We have to go all the way between the 3 and the 1, because that's a number between 1 and 10. So we get 3.125 times, we moved it 9 times, so times 10 to the 9th. Alright? Alright, why don't you guys try B? Pause the video and give it a shot. Just try B. Alright, so if you put the decimal there, because that's where it really is, even though it's invisible, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 times. Do we place it right between the 1 and the 4? 1.42 times 10 to the 13th power. 13 jumps. Right? 3, 6, 9, 12. Yeah, okay. Try C. Pause the video and try C. Alright, so you should get 1 jump, 2 jump, 3 jumps, 4 jumps, 5 jumps, 6 jumps. That's all you gotta do. 6 jumps, and you're at now 3 times 10 to the 6. You could do 3.0 times 10 to the 6, or just 3 to the 6. They're both equivalent. Alright, so that's how you convert big numbers to scientific notation. And small numbers is pretty much the same thing, but the opposite. And you'll notice that for big numbers, that equals a positive exponent. 10 to the 9th, 10 to the 13th, 10 to the 6th. But for these small numbers, we're going to have negative exponents. So let's take a look at D. Let's scooch this decimal over until we get a number between 1 and 10. So 1, 2, 3, 4, 5. Now we're at 2.51. That's where the decimal point is. Is 2.51 between 1 and 10? C, as they'd say in Spanish. So we moved it 5 times, so we're going to multiply by 10 to the negative 5th. This is a very small number. It's a fractional amount, if you remember from last unit. It's a fractional amount, so it's going to be a negative exponent. All right, why don't you try, here, I'll do E with you, and then you can try F. 1, 2, 3, 4 moves to get to 9.0, or just 9. So 9 times 10 to the negative 4th. Pause the video and try F. All right, for F, let's move this decimal. 1, 2, 3, 4, 5, 6. So 3 times 10 to the negative 6th power. All right? All right, you got some mixed practice here for G, H, and I, so why don't you guys give those a shot? All right, so for G, if you're doing this on a Google Doc, maybe you wrote down 4.03 times 10 to the, like in words, 10 to the 12. That's okay. If you took that note and you're actually doing it like with the equation format, that's cool too. This one you should get 1, 2, 3, 4, 5, 6, 7. 7 moves. So it's going to be 3.2 times 10 to the negative 7th. It's a small number. And then this one, 1, 2, 3, 4. 8 times 10 to the negative 4th. Or 8.0. I'll do 8.0 there. All right. Part 3 here. Convert the numbers written in scientific notation into standard form. So what's different about these? Well, in these, we have the scientific notation. We want to make it look how we're normally used to seeing numbers. So let's give it a shot. I like to rewrite these. 3.13 times 10 to the 7th. Then I also like to ask myself, is this going to be a big number or a small number? Well, to figure that out, I look at the exponent. That tells you it's positive. It's going to be a big number. So let's scooch this decimal over 7 times. Not add 7 zeros. Do not add 7 zeros. Move the decimal over 7 times. 1, 2, 3, 4, 5, 6, 7. And then if I zoom in really careful here, between each jump, I'm going to put a 0. Because if there's no number there, but we're moving the decimal, we have to fill it with a number. And the best number to fill it with is 0. All right? And then what I'm going to do is just rewrite the number nice and neat. So it looks like I have 5 zeros here. 1, 2, 3, 4, 5. And then I'm going to put my commas to make the number even more neat. So that's my final answer right there. Written nice and neat. All right, let's try B. We're going to move the decimal over 5 times to the left because it's a small number. 5.18. So here we go. 1, 2, 3, 4, 5. And then we'll put a 0 between each jump. 0 there, 0 there, 0 there, 0 there. Now the decimal point is right here. So we're going to have point 0, 0, 0, 0. There's 4 zeros. 5, 1, 8. All right. C. Last one I'll do for you here. Actually, you guys try C. Pause the video and try C. Okay, so for this one, there isn't a decimal place. But 4, if you have the number 4, it's really going to be right there. So 1, 2, 3 is all you need. 0 between that jump, 0 between that jump. The decimal point is now here. So we're going to have 0.004. And I'm going to throw in this extra 0 out front because that doesn't change anything. That's how you'd normally see it on your calculator. All right, so pause the video, try D, E, and F, and then you'll be good to try the assignment. Okay, so for D, you're going to be moving it 9 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. Right here, you're going to get 3, 2, 9, 4, and then 2 zeros at the end there. And then for this one, you're going to get 0.031. You don't really need this 0 here, but I like to put it just because that's how you'll traditionally see it. All right, so that's all I got for you guys today. Have a great rest of your day. Rewatch the video. There's definitely good info in there. And then tackle this assignment, the last one of the week. Alrighty, take care, guys. Have a good rest of your day.